Hello viewers, in this video I would like to discuss CS Main 2011 question number 1D of Operations Research. This is from paper 2 Mathematics. The problem is solved by Simplex method. The following problem, this is LP problem, linear programming problem, and it is maximize z is equal to 5x1 plus 3x2 and constraints are 3x1 plus 5x2 is less than equal to 15, 5x1 plus 2x2 is less than equal to 10. So x1 x2 are greater than equal to 0. This question is of 15 marks. So first we write the problem in standard form. So given linear programming problem, we are writing in standard form by adding slack variables, because both of the constraints are having less than equal to sign. So we will be adding slack variables, means something is less on left hand side. So we rewrite it, maximize z is equal to 5x1 plus 3x2 plus 0s1 plus 0s2. I will come back to this again. Subject to this first constraint is 3x1 plus 5x2 plus s1 is slack variable is equal to 15, and 5x1 plus 2x2 plus s2, this is again slack variable, is equal to 10. So in objective function we write 0s1 plus 0s2. So now four variables are there, x1, x2, s1, s2, these are greater than equal to 0. We rewrite the objective function in the equation form and we bring these two on left hand side. So this becomes z minus 5x1 minus 3x2. We to solve the problem by 0s1 simplex method, we write down the problem in tabular form and we call it iteration 1, in which s1 s2 are basic variables and value of s1 is 15, value of s2 is 10. Non-basic variables are x1 x2, which we have taken 0. In this table we are writing z, x1 x2 s1 s2 and solution. Z row shows the coefficients of z equation, which we have written in the previous slide. So coefficient of z is 1, coefficient of x1 is minus 5, coefficient of x2 is minus 3, s1 is 0, s2 is 0 and solution is 0. And s1 row shows the first constraint in which slack variable s1 is coming into picture, and we have written coefficients of z, x1, x2, s1 and s2, which are 0, 3, 5, 1, 0 respectively. Similarly, we have written the s2 row in which we have written coefficients of second constraint where slack variable s2 is coming into the picture. So after doing this, we got this first table, starting table, which we have called iteration 1. We find out most negative value in z row, because this is the maximization problem and we have to find out most negative. So coefficient of x1 is minus 5, which is most negative. We got the pivot column, this column is pivot column. Now for finding the leaving variable, we use the elements of solution column and divide elements of solution column by corresponding elements of pivot column. So we get the ratio as 5 and 2. 2 is minimum, so corresponding variable s2 is the leaving variable. Now for further calculation, we do these calculations with the help of these formulas. So s2 row, which is the pivot row, now we divide it by 5, that is the pivot element, and we divide this row by 5, so we get the new s2 row, and in next table we replace s2 by x1. For writing s1 row and z row, we use these two formulas. So new s1 row is s1 row minus 3 new s2 row, and new z row is equal to z row plus 5 new s2 row. So we got this table. Let's do one example here for calculating the elements of this table. Let's see this minus 1, and we got minus 1. How? So this is z row, so new z row value is minus 1. How we have got it? So z row was earlier corresponding to x2 was minus 3. So minus 3 plus 5 into new s2 row. New s2 row is 2 upon 5. So it means minus 3 plus 5 into 2 upon 5, which becomes minus 3 plus 2, which is equal to minus 1. Similarly, for each element we will be doing this type of calculation, and we got this one. We see, check the z row again, and we see minus 1 is still there, negative element is still there. It means we have to do some further calculations. So coefficient of x2 is most negative. It means this is our pivot column. Now we find out ratio with the help of solution column, and each element of solution column we divide by corresponding elements of pivot column. So we got this 45 upon 19 and this 5. So this is the minimum one, and we got s1 as leaving variable, and 19 upon 5 is our pivot element. So we divide s1 row by 19 upon 5, and with this new s1 row x2 will enter, s1 will leave. So in next table we will write here x2, and with this new row we will be changing our z row and x1 row by the following formulas. We write the next table with the help of these formulas, and these are x1 row is x1 row minus 2 upon 5 into new s1 row, and new z row is equal to z row plus 1 new s1 row. So we got this table after doing calculation as we did in previous one element calculation we have done. So we got this table, and in z row we check there is no negative element. It means we have reached to our optimal solution, and optimal solution gives us values as x1 is 20 upon 9, x2 is 45 upon 19, x1 is 20 upon 19, x2 is 45 upon 19, and z value is 235 upon 19. So we got our solution, and objective function value is maximum, which is 235 upon 19. Thank you.